I wanted to make a video showing my F5D friends how to set up and configure an F5D motor and an ESC to fit in an F5D airplane. In an F5D plane, there's little space, so we have to perform a couple of tricks, some clever wiring and good soldering techniques to get the ESC and motor as compact as possible, but also reliable without putting stress on solder joints, and packaging the ESC and the wiring so the unit will stay reliable and the wires won't get stressed or come apart later. So we usually use new motors, and I'm usually use a Castle Edge Lite 75 ESC. Before the Edge Lite series, I used the Ice Lite series, which didn't have a heat sink on it. The Edge Lite series has a heat sink, which I remove. Probably not advisable, but my friends and myself have been doing this for a long time. And in the relatively low current draw from an F5D setup, around 60 amps, and then the short flight time, just a minute, the ESC seem to be able to handle it just fine. So here's how I do it. Okay, the first thing we do to prepare to remove the heat sink is cut off the heat shrink tubing carefully. I use these curved Lexan scissors, but you can use whatever works. So there's the unit without the shrink tubing. Okay, the next thing we're going to do is remove the heat shrink. I use an X-Acto large chisel blade and a wood mallet that I made in Mr. Gary's shop class my freshman year of high school. Just put the chisel between the bottom of the heat sink and the ESC and just lightly tap it. Crack that side loose. Now do the other side. And carefully pry it away. Now it's still stuck to the so just pry it off of that. And that's it. Again, surely not recommended by Castle Creations. I'm sure they would cringe at this. And you do this at your own risk, but there you go. The next thing we'll do is remove this ferrite ring, apparently used to reduce RF noise that could cause interference. Again, surely not recommended by Castle Creations, but something I've been doing for a long time with 2.4 gig radios. They seem quite reliable, and this is something else I do just to make the ESC more compact. Since the wires that come on here, the signal wire is so long, it's much longer than we need for an F5D plane. So I'm just going to go ahead and cut the wire randomly at an extra long length, and then just remove it unwind the wire from this ring. Still, the wire is probably about 6 inches longer than we're going to need for an F5D plane. Later on, I'll use my Hansen crimpers to install my own servo connector on the end of the wire at the length necessary. Okay, the next thing we're going to do is remove this white wire, which is for reading data real time when the ESC when the motor's running. We're not going to use that feature, so I'm just going to go ahead and get rid of this wire. So we're going to take off this label and strip the wire from the main bundle. Cut the clear heat shrink holding the top board to the bottom board. And then just desolder this white wire. Make sure the solder from the wire doesn't contact solder from any other parts of the board there, so there's no short circuit. I always use new or mega motors, but I'm experimenting with a different motor today. Anyway, the most important thing here is to arrange the wires neatly, and so there's as little stress as possible on the wires and on the solder joints on the ESC and on the motor. So it takes a little bit of clever finagling to get the wires the way you want, but we also want to make the ESC and motor unit as short and small as possible. So what I do is I will bend gently bend the ESC wires down under the ESC and interpose, if you will, the motor wires between the ESC wires. So what we're doing now is we need to find out how short to cut the ESC wires. Do not cut the terminal wires on the motor. So what we're going to have is a unit it's about as far forward as we can go with the ESC on the motor, which is pretty short. And now we're going to double over the ESC wires, make it a nice smooth loop there. And now this shows us about where we need to cut our ESC wires. So I'll mark one of the ESC wires. We're going to cut them all the same length, so you don't have to mark them all, but they're going to be cut about here. So here's we're going to cut the ESC wires. Again, when the wires are folded over and connected to the motor, this is about what we're going to have right here. Now for the soldering. One of the most important aspects of soldering is tinning the wire. That is, saturating it, coating it with solder to accept the solder on the other piece of wire. So I actually dip the end of the wire to be soldered in the soldering flux. Apply solder to the iron. I dip it in again. Apply solder to the iron and the wire. There you go. One wire that is thoroughly and neatly tinned. Two more to go. Dip it in. Get solder on the tip of the iron. First tin it again. That braid drinks up a lot of solder, so you might need a couple of attempts. There you go. And one more. Twist the wire again. One of the most important aspects of soldering is the transfer of heat. Heat has to be transferred from the iron to the part being soldered, and what's better to transfer heat than molten solder? Which is why you tin the tip of the iron with solder and then transfer that to the part being soldered to the wire. So there, 3 neatly and thoroughly tinned wire ends. Now, the terminal wires on the motor are also pre-tinned from the factory, but I like to tin them again just to make sure the soldering I'm using will work with the solder on the wires, which sometimes is slightly different, but just want to make sure they tin well. And maybe add a little more solder. Maybe add a little more solder to the wires too. There, those tin well. Having both sets of wires thoroughly tinned will make for an easy and a proper soldering job when it's time to join them together. Now we have to know how we're going to join the wires, how they're going to be positioned when we solder them together. As I illustrated, this is going to be how they end up, how the ESC and motor are going to end up, about like this. Of course, we can't solder them together this way, so the ESC is going to flip over like this, and this is how the wires are going to be joined. Now, it doesn't really matter which wire you join to which wire, because if the motor runs backward, all you need to do is get into the ESC programming and reverse the direction of the motor. So I'm going to put the motor in a vise to hold it so I can solder the ESC onto it. So here's the motor clamped in a vise, lightly clamped in a vise, and ready for soldering. Can use hemostats or something like that to hold them close. Another key is to try not to move the wires while the solder's cooling. 3 sets of wires, soldered shiny, so I'm pretty happy with that soldering job. Now that we've got our ESC and motor soldered together, let's fold them in half and see what we're going to have. Try to neatly intertwine the ESC wires with the motor wires. And when it's folded over and heat shrinks together, this is about what we're going to have here. Still a pretty compact unit. If you need to, if things don't add up, if the length isn't right, go back and unsolder and cut wires as necessary and resolder to get it to fit neatly. Now I've protected the solder joints with not 1 but 2 layers of heat shrink tubing, because when those wires are folded over the ESC and on the board, there's no way we want any chance of any shorting out or anything like that. I've also now wrapped the top circuit board to the bottom circuit board with this self-healing, self-adhesive electrical tape. You can get it at automotive stores. And I've also wrapped the front of the wires to the board for a nice compact flat unit that will now get wrapped in fabric heat shrink. One other thing I like to do before I apply the shrink tubing is I like to put a generous dab of Zap Goo or Shoe Goo or something over the signal wires to the ESC to act as a little bit of a strain relief. On the solder joints there. There, I've now wrapped the wires in the ESC in fabric heat shrink tubing, and the motor will fit in front of the 2S battery, and the ESC will be neatly supported by the 2S battery, and the 2S plus 3S configuration we use for F5D. And then you can cut and solder connectors onto your discharge wires and onto your signal wire as needed.